How's it going, guys? It's Jiggy here, and in this video we're going to be taking a look into the maths behind functional programming. Now there are three main components to a function that we're going to go through. These are the arguments, which come from something we call a domain, the function itself, and finally the results, which come from something called a codomain. So let's crack on. First of all, let's define exactly what a function is. As we spoke about in our introductory video, a function is a rule or operation which maps an argument to a result. Now, argument and result are two new terms that we've introduced, so let's go ahead and clear those up. Now, an input can also be called the argument, and the output can also be called the result. So we now have three components to the function: the argument, the function, and the result. Let's have an example. If you had a dishwasher, you would input dirty dishes into it. So, dirty dishes is your argument. It would apply the clean function, and it would output clean dishes, which would be called your result. Now that we've established this, let's take a look into the argument and how the domain fits into things. First of all, an argument has a type. This is simply any data type, such as an integer, a string, a boolean, and so on and so forth. In our dishwasher example, our type would be a dirty dish. So where does this argument actually come from? Arguments come from something we call a domain, and a domain is a set of data with the same data type from which arguments for a function can be selected. They are a valid set of input values that you can provide to a function. Let's apply this to our dishwasher example. What would be our domain? In this case, it would be any dirty dish, for example, a used bowl or a used fork. These arguments for the dishwashing function are taken from the domain of dirty dishes, so we can call that our dirty dish domain. Things that would not be included as a valid argument for the dishwasher function, and hence would not be present in the domain, is something like a car. That's just not going to be accepted by a household dishwasher, as you can probably tell. So now that we've discussed the argument and the input, let's talk about the result and the output. Now, just like an argument, the result also has a type. Again, this can be any data type, such as an integer, a string, a boolean, and so on and so forth. In our dishwasher example, the result type would be a clean dish. So where did these results actually come from, and how do we know that they're valid? Well, results come from something we call a codomain, and a codomain is a set of data with the same type that can be outputted from the function. So essentially, they're a valid set of results after applying the function to the argument. Our codomain of clean dishes means that the dishwasher function must output a clean dish. The reason we have a codomain is to define a valid set of result values, which enables us to check if the function is sound and works as we expect it to. If our argument was a dirty fork, and the dishwasher outputted an even dirtier fork, well then there's something wrong with the dishwasher function. Let's put the codomain and the domain together. A function is going to map a value from the domain to the codomain, like so. So the dishwasher function is going to map a dirty dish from the dirty dish domain to a clean dish in the clean dish domain. The functioning of a dishwasher is fairly self-explanatory, but let's talk about a more technical example. Suppose we needed to write a function that mapped you and your classmates to a numerical ID using your classmate's favourite food. Now before we go ahead and define that function, let's discuss the argument type. The argument type for the domain will be a string and may have these values, for example. Now you can see that the domain is essentially a subset of the string data type, since there's going to be a finite set of favourite foods that a student may choose. Now the result type would have to be an integer in order to store the ID, since it's going to be numerical. Some potential values we could have are 27, 59, 126, and any integer for that case. Now let's talk about our function, which is going to map the argument from the domain to result in the codomain, like so. Our function is going to add up the characters in order to produce a result. Let's say A is 0, B is 1, C is 2, and so on and so forth. That means that banana is going to be mapped to 27, rice is going to be mapped to 33, and butter chicken is going to be mapped to 126. Now you may see that 59 and 177 are not mapped to, and that's absolutely fine, since there's a rule that says that not every value in the codomain must be mapped to. We can formalize functions and say that they all have this type that we see here. So we read this and we say that there is a function f which maps a value from domain A to a value in codomain B. And we're done. Let's have a quick recap of some key points. A function is an operation which maps an argument from the domain to result in the codomain. The domain is a subset of its data type, such as an integer or a string, and not all codomain values must be mapped to.